So today we have the pleasure of welcoming back Sebastian Weber to our LEOMO webinar series. Sebastian has been the head coach of professional cycling teams of the highest ranks for more than 10 years. He is a renowned sports scientist, owner of INSYCD, and has coached athletes to win numerous victories at the Tour de France, Giro, Vuelta, multiple world championships, and Olympic medals. In this webinar, Sebastian will demonstrate how LEOMO's motion analysis technology helps athletes maintain the optimal TT position in real time. This will be done with our newest feature, Target Range, which we are very excited to officially present to the public. Remember, during today's call, we encourage everyone to ask their questions in the Q&A tab, and questions can be answered via chat throughout the webinar. After the presentation, Sebastian will also do the Q&A sessions himself. And without further notice, let's welcome Sebastian Weber.
Yeah, thanks a lot for the introduction. Good evening, good morning, good afternoon, everybody, depending on where you are, or good night if you're over there in Asia. I heard of people actually setting their alarm in the middle of the night to see LEOMO webinars. That's great. Hope you're doing all good and yeah, stay safe. So as introduced, my main topic today is going to be using some of the LEOMO features and especially the Type S device specifically for training for time trials. And to give you a heads up, this is not specifically targeting bike fitters or coaches, but for today, I would like to focus on more on the athlete side of things. So how can an athlete really utilize the Type S to improve his time trialing? And why do I feel entitled to talk about this? Already, as said in the introduction, I've been working in professional cycling for many, many years with a specific, or my specialty, so to speak, was always sprinting and especially time trialing. I've coached guys like Tony Martin and some others who I was lucky to maybe help a little bit to win time trial races and especially world championships. But besides that, for those of you who may not know, I actually started coaching amateur athletes and recreational athletes, and I did have my own coaching business where we coached amateur athletes and recreational athletes. And I'm mentioning that because the things that I'm showing here really are really suited for also you guys who are maybe not professional, right? And my background is mostly in coaching, but because my aim always is and has been to improve the performance, especially in terms of speed. When it comes to time trialing, we also have to talk about aerodynamics. We also have to talk about biomechanics, and we also have to talk about being more efficient. And this is actually where the professional meets the amateur athlete, because nobody can afford to waste time or money or energy into their sport. The professionals cannot, because they are already on the pinnacle of what they can do in terms of training, and the non-professionals cannot because they're already sacrificing their time crunch schedule and need to be as efficient as possible. And these are some things I'm going to talk about today, how we can use the LEOMO technology to make you more efficient and train better. And I had my presentation finished, roughly end of last week, and then I actually watched a little bit of the Ironman virtual racing last Saturday. And sorry for the bad quality in this screencast. It seems like the bandwidth was really bad last Saturday. But what you can see here is, when I watched this, it's funny because I rarely see somebody in indoor riding in these events riding in the aero position. And that's something a little bit specific maybe for the indoor riding, because outdoors you would be most likely riding in your aero position, right? Because you can feel the wind and you can feel the higher drag. Now, especially in these days, in these difficult times with several lockdowns and stuff, where you maybe train more indoors, what might happen is that you're actually training not as efficient because you maybe hit the power numbers, but if you don't train in your actual position, then you're only getting so much, you're only getting a part of your training effect. Because the training is not only the power, so to speak, but it's also staying in this position. And I just, recognize, and therefore I wanted to bring this into today's presentation here, is that obviously riding indoors, people are not really staying in their position a lot. And then there's another issue with riding indoors. Well, we could start talking a lot about that. On a trainer, your position, your riding style is maybe not exactly the same. You can imagine that if you do indoor riding, you will be familiar with the problem that riding out of the saddle, is not the same as outdoors, because you cannot move your bike as good left and right, and therefore you cannot really use your own body weight as good as you can outdoors when you ride out of the saddle. But there's one thing that people are maybe not aware of very good when it comes to indoor riding. And this one thing is really, really, really has the potential to mess up your riding position and riding style while riding indoors. And that's the power output. Because when we are accustomed to riding mostly outdoors, and we are accustomed to our power numbers, right? We have our FTPs, we do have our, training zones, whatsoever, all based on power. I mean, heart rate doesn't work indoors great as well because of the heat, because of the heat and the missing cooling effect. So heart rate is a difficult metric to base your training on in terms of intensity. So everybody's training on power. But power indoors is not necessarily the same as power outdoors. And I brought you some scientific studies, for today, so that you can see that what I'm telling here is not my personal opinion, but it's actually pretty well known that that riding indoors in average results in lower power numbers. And what you can see here is a simulated 40-kilometer time trial with a very significant, like 15%, and this is the typical number that we can easily see, about a 15% drop in power output. And you can see from the numbers that we are not talking about professionals, right? You can see indoor riding produces or enables people to push less power. So it's not a big problem, so to speak. It's just a problem of being aware of that, okay? If you say, okay, that's maybe only the untrained or not the highly trained athletes, I have this study for you. It's a different one where you can see 8 subjects, and if you look at the power outputs in the upper section, there are different trials also to see the tolerances, so to speak, within the different trials, and you can see that, for example, subject 1, the mean power output between indoors and outdoors is basically 0, and then you have other subjects where you're talking about 20 watts easily, right? That's most people here. Here, that's a typical number. In this case, it's only 6 watts. So why is this a problem? This is a problem because if you don't know about this, and if you don't know the exact difference, or you're not even aware of the problem, then you might try too hard indoors to achieve the same power as you're accustomed to and as you know from yourself from riding outdoors. And what is pretty easy to understand, I guess, what is known is that if you go into riding indoors or outdoors, doesn't really matter, and try very, very hard to hit the same numbers, one of the first things that you are sacrificing is the quality of your riding, right? And therefore, it starts with being aware, right? So average power numbers, that's what you see here, right? Average power numbers indoors are lower. There are physiological reasons for that. We're not going to dive into this here now, but it's basically to the trainer that you're using. So that's a little bit the problem with the indoor riding, having the higher potential to mess up your position, which is a pity. Because if you think about that, indoor riding, is naturally the best possibility to focus on, you know, very good riding position and very good technique, right? You could even put your trainer in front of a mirror, so to speak, and see you, you know, check your own position while you're riding. And nowadays, if you're trying to stick with the power, we easily mess this up, right? So everybody is, you know, so to speak, very focused on power output. But at the end, if you're not indoors but outdoors, the question is, how fast are you actually riding, right? Coming back to our time trial topics, the question is not how much power you put out. That's not the guy who wins. The guy who wins is the one who is the fastest. And as you will be very well aware of the problem that the power demand for increasing speed is exponential. So that's what you can see here. You have the power output on the y-axis, and you do have the speed on the x-axis, right? And what you can see is that obviously power output has this curved linear shape. So that means, to get this straight, especially at the higher velocities, if you increase your power a little bit, it's not going to buy you a lot of speed, right? So we are training very, very hard to increase the power output, but the amount of speed that it buys us is at some levels only mediocre. And this is because obviously because of the high aerodynamic drag coming up here, okay? And we will come back for that, right? So because the question we need to tackle when we talk about time trialing is basically how much power do I have and how much speed do I get for that, right? Because increasing your power, as you all know from training, isn't the most easiest thing to do, right? It's not just I can just download a training program from the internet and do this training for 6 weeks, and then my power at FDP or my power for 10K time trial or my power for the Ironman goes up 25%, right? That's normally not how it is. So, you know, increasing power, so to speak, is you know, a very limited strategy when it comes to increasing speed, right? There's only so much you can gain. However, when you're out there training and monitoring your training data, what do people normally monitor? Power output for sure, right? That's one of the most common things. Heart rate, cadence, maybe some other metrics, altitude, distance, time, stuff like that. Okay, but if the power output is only giving so much information about how, you know, how fast you can ride, what other metrics can we look at? And again, when you are interested in riding faster, and if you are a little bit familiar with time trialing, you will be very familiar that your main opponent, so to speak, the key to ride faster is overcoming drag. And so therefore, we should ask the question, if drag and posture are one of the most important things, why don't we look at these things? Why don't we capture posture? And I give you one easy example for today, which I kind of picked for this webinar to focus a little bit more, and that's torso angle, or you can also say upper body angle, right? There's another one you might want to look at, it's pelvic angle, right? So what's about these metrics? If those metrics are, you know, highly important for gaining speed, and that's what I'm going to show you in the next couple of slides here. If those metrics are highly important and the effect of those metrics on your riding speed is maybe even bigger than the effect of power output, well, then we have to ask ourselves, why do we measure power output and why don't we measure torso angle and pelvic angle? And by the way, I had a nice discussion with you know, one of the most successful guys these days in track pursuit racing about aerodynamics. And this is actually what, you know, the people who, you know, a couple of weeks ago broke the team pursuit records, world record several times, right? This is what those people are really, really looking on and really, really focus on. Being able to keep the best posture, being able to keep the most aerodynamic position during a race. And if you've maybe followed the last Track World Cycling Championships, it was very, very impressive, the outcome of that. So that's maybe similar for what you guys are doing in terms of most people these days get a professional bike fit, right? Either you go to a bike fitter and you use whatever kind of technology to get a bike fit. You get a retool. People use the LEOMO. Some people use the Biomechanics. Or maybe you just take your iPad and film yourself from a side view and post it on a forum or something. But bottom line is there is some kind of awareness and some kind of knowledge about the importance of a good bike fit. And I'm coming, as I said initially, as I said in the beginning of this presentation, I'm coming from more like a coaching background. So my coaching business was mainly on performance testing. So before we go ahead, let me give you this little metaphor here. If you would not have a power meter on your bike, and if you would not have a heart rate monitor on your bike, would you go into a laboratory or to see your coach to make an assessment about your threshold and about your training zones? I think in most cases the answer is no. If you look into a forum, triathlon, cycling, whatsoever, and you say, hey, just make a new post and say, I'm thinking about doing these kind of performance assessments, but I don't have a heart rate monitor and I don't have a power meter during training. And the most answers that you will get is, well, if you can't follow up, if you can't see these metrics in training, then there's no point. It doesn't make sense to get the assessment. And I'm using this analogy here a little bit for the bike fitting. Don't get me wrong, I'm not bashing bike fitting. I'm not saying bike fitting is a bad thing. I'm just saying that it's funny that we do bike fit in the lab or in the wind tunnel or in the velodrome or just in our bedroom in front of the mirror. But then we have a very, very poor understanding on how good this bike fit actually translates into training, right? And this is, I think, one of the most important points here when it comes to the practical understanding, okay, of it. So the question is, when you have your position dialed in from a lab scenario, then how much and when are you actually riding it, right? How much time do we actually spend in the position? Because again, I can ask everybody, how much time did you spend in your training zone? How much time did you spend in your, in your heart rate zone or cadence zone or whatsoever? And you can just look at your bike computer and you can tell me, and you know it before you change and before you shower. But again, like position is kind of a blank spot, right? So the one thing I wanted to introduce in terms of time trial, which is, I think, very well known as being one of the most decisive factors when it comes to aerodynamics, and therefore when it comes to riding fast, because this is what riding fast is about, is aerodynamics, are those upper body angles, right? And there have been nice studies, looking at different upper body angles, for example, and how this correlates with your drag area, right? Obviously, it's not a super tight correlation, but in general, I think it's easy to understand that when you lower your upper body, right, that you have less frontal surface area. And frontal surface area is actually one of the main decisive factors of your aerodynamics, right? Basically, if you have a smaller footprint, then you have less drag for a given body shape, so to speak, all right? And this is where the torso angle kicks in. What I've done here, I computed the projected frontal surface area based on the scientific literature using the torso angle. So what you can see here is the frontal surface area, which is then becoming part of the CDA value on the y-axis, and you see the different torso angles on the x-axis. right? So torso angle, obviously, right, basically being lower with your upper body, obviously results in lower projected frontal surface area. Okay, so therefore this angle is very important. Now you could just say, okay, well, I don't need to measure that, right? I don't care. I just, you know, get my upper body horizontal. And if you're a professional athlete, and especially if you have been like whatever, like, you know, 10 years ago or something, that is most likely how your aero fit in a World Tour cycling team could have looked like. As long as possible, as low as possible, that's it. Now, it's not as easy as that. There is a trade-off, and you don't need to read this whole abstract here. I just want you to focus on the last sentence, which is, you know, kind of known, that there's a trade-off. Lower isn't always better, not for aerodynamics on the one hand, but also not physiological functioning. So what might happen for you know, physiological cost and for cooling and for also for aerodynamics is that when you decrease your aerodynamic drag by decreasing your torso angle, by lowering your upper body, then you might easily buy this advantage, so to speak, by the cost of an energy loss. Okay, so it's not as easy to just put out one number out there and say, okay, you know, bring your upper body to a horizontal position. That's not necessarily the most aero, because maybe your head sticks up, and it's also physiologically maybe not the best thing to do, right? And it really comes down to understanding the angles. And here's one example. One of the recordings out of training here. This image might, you know, on the first glance, you might think that the pelvic angle is much different, but actually the leg is in a different position here as well. If you look at the pelvic angle, so to speak, and you compare the angles, then you can see that there is actually a difference in those postures. And to see that and to quantify that with your blank eye is obviously not that easy, right? So doing it in front of a mirror or with your iPad has a limited capacity to really monitor your body angles. That's one point. The other point is that it's very difficult to take your mirror or something out there in training. So let's look at what is happening outdoors when you're actually training. So what you see here is a training ride of Tony doing some hill reps here. You see the power output in red, so he's doing intervals, right? And you can see this slope in the heart rate, right? You can see that especially in the second and the third interval, that heart rate is creeping up. So you have an indicator for some physiological fatigue here, right? When you have this uncoupling, you can see in the first interval, purple heart rate more or less stays kind of in a steady state with steady power output. And then for the second and for the third one, especially in the third one, because the power output increases in the last one, in the last effort. But you can see very, very significant increase in heart rate. Okay, so there is a physiological reaction here, and as I said, it's energy cost, and it's also, you know, partly could be cooling, especially when it's on a climb here. And this is a torso angle that goes with that, right? This is a torso angle you can see in the first one, where you don't have this big shift in heart rate. You have a drop in torso angle, not a lot, but you have one. And then in the second and the third, torso angle, you know, decreases even more. So he's not able, that's the main point here, he's not able to keep his torso angle during these intervals, right? And this is, you know, this is a professional athlete. It's not, and he's a pretty good time trialist, damn good time trialist, and he's not able to keep this position, right? But he has a heart rate drift. So you have the clear link between the physiological metrics and the position on your bike, okay? And if you don't see the torso angle, obviously you don't know. I can say, okay, I'm not interested in heart rate, you know, it's a soft metric. I'm not interested in torso angle, I'm just interested in going faster. So show you something else. This is a torso angle from a long session, from a long interval, okay? Trying to be as low as possible with the torso, trying to stay low during a TT effort, okay? During a hard effort. And you can see that the torso angle is creeping up from approximately 20 degrees up to, 25, 26, 27. So what does it mean, right? You can say, okay, it doesn't tell me anything. 20 degrees, 25 degrees, I don't know. So let's do the math behind that. With a torso angle of approximately 20 in the beginning of the interval, the CDL value is 0.225, pretty low CDL value, but that doesn't really matter at this point. Which means for him, oh, sorry, and at the end, the CDA is approximately 0.2335. So you can say, okay, well, still, I'm not very familiar with the CDA values, but fair enough. What does this mean? This means that at the beginning of the exercise, at the beginning of this time trial simulation, he was able to ride with 300 watts, 43.4 kilometers per hour. But because he loses his perfect position during the simulated time trial, and the torso angle goes up, so he's not able to stay low on the bike. For the same power output, his speed drops. Or in other words, basically, he loses aerodynamic efficiency. This torso angle shift costs him 10 watts or 0.55 kilometers per hour of speed. And again, it's 10 watts that is there. It's 10 watts that the athlete is actually physiologically capable to produce. He just needs an additional 10 watts because he's not able to hold his position. And from a coaching perspective, as I said, I'm coming from a coaching background. From a coaching perspective, you cannot afford that. You simply cannot afford that because gaining 10 watts in your time trial power is nothing that happens overnight. And when you have those 10 watts, why waste it on bad posture, on bad bad aerodynamics? Because I'm not talking about aerodynamics that is not possible for the athlete, right? In general, it's possible to have a 20-degree torso angle in this case. So it's not something that doesn't seem achievable, right? So that's why, and that's how you can use those angles to really understand your position on the bike while you are out there. And this is also why it is important, performance-wise, why it's performance-wise important to understand this. And because we understand it's so important, actually, almost maybe 10 months ago or something, I approached the developer team of LEOMO and asked if we can help the athlete to visualize that, these changes, right, these ranges. And what they came up with was a feature that is called the target range, okay? And that's something I would like to explain here today a little bit, because for me, from a coaching perspective, this is really where you, as an athlete, can easily start to utilize the angles in your training, okay? And what it allows you to do in a short way, it allows you to set up something which you can easily call training zones, but not a training zone for heart rate or for power or for RPE, but it can allow you to set up a training zone in terms of your position, right? So you can define for different positions, riding on the drops, riding riding on the hoods, arrow position, tucked in arrow position, riding out of the saddle, you name it, right? You can name it yourself. You can see here already in the screenshot, we do have some Oh, we do have a typo, by the way, sorry for that. But we do have some, different baselines for some different ranges for the TT bike and for road bike and so on. And what's hidden behind this setting is basically that for each position, for each bike, or each position, like a perfect aero position, riding on the hoods or whatsoever, I'm now able to define a certain range of angles which I am allowed, so to speak, to stay in. So I have like a training zone. I have a zone for a specific angle. So if you want to go back to the example with a torso angle, saying torso angle is maybe for time trialing one of the more important, or one of the maybe most important angles, you can actually now define this angle for your time trial position, right? And then use it to make sure then you go out there training that you actually stay in this position, right? And not lose the position, so to speak, right? And let me show you how this works. So basically, step by step, the idea is, for example, for time trial, you ride in your perfect position. So we go back to our indoor training, we go back to the bedroom, we go back riding in front of the mirror or whatsoever, right? In a non-fatigued, easy situation, right, where power output is not high, where, again, you're not fatigued, you're not tired, you maybe ride, you stay in your perfect position, which you have from your aero fitting or wherever it may come from, right? And you really focus on that. And then basically what you're doing, you press a lap button on the type S and you record a lap. Few minutes is enough, very easy, okay? And then you can provide a specific name for that, right? You can name it like tucked in or shoulder shrug or just TT or whatsoever, right? It's totally up to you. You can define a name for that. Okay, and then it's set up in your type S. You might, if you want, you've seen it in the previous slide, you can actually edit the values manually, right? If you want to do that. And then you can select the range during training as it's needed, and you can control and train in this position. So as you would have an eye and watch and monitor your power training zone, you can now watch and monitor the correct body position training zone and make sure that you're actually staying in your aero position. You can monitor how long do you stay in your aero position. Again, I can ask you how much time did you spend in your training zones, you could tell me immediately after training, right? But if I ask you how much time did you spend in your aero position, nobody knows, okay? Now you can, and that's what it's set up for, okay? And because of that, I really wanted to give you some ideas on how you can use this in training, okay? So first thing is, you don't know what you don't know. So if you don't monitor that, if you don't monitor your position in training, you don't know how it looks like. It's like, think about take off your power meter, take off the heart rate strap. You don't know what's the power and what the heart rate is. Similar thing here. So how to do this? Very, very simple. Create a target range for your perfect position. For example, your time trial, right? Start on the rollers where you really can concentrate, record this, and then use this range during regular training sessions, okay? And then you maybe want to target on specific training situations, right? So when you do your specific interval training in your TT position, right? You want to look at this. You want to look at your target range for your torso angle, pelvic angle, and so on, right? You also want to keep a special eye on what happens to these angles at the end of the ride, right? Because at the end of the ride, I might see fatigue, and therefore it changes. And you also want to keep an eye on that, what happens with your target ranges with different cadences. So the first goal for you to utilize that is to get an understanding of what are the common common ranges, or how good you're able to stay in this range. And you will be surprised, I can tell you. You will be surprised how difficult it can be, and we just seen it with Tony with his interval training, how difficult it can be to actually stay in that range when you do specific sessions, which are mainly only created by your coach based on power numbers and not based on being aero. But again, if you're just focusing on power, you're not aero, then maybe what you gain in power does not buy you any speed, right? And it's, at the end, it's about speed. So therefore, the next thing that you want to do, once you've familiar how to use it with training, you want to apply it to racing, okay? And that's, again, very, very simple. Make sure that you have your target range, which you kind of validate. You have your common zone, common training zone from the previous trainings, and then you use the range which you normally had for training. You just use it in the race, and you want to understand how much time you're able to spend in this zone. Do you spend either on the lower end, on the higher end, for example, on the torso angle, or are you maybe not able to stay in this zone at all? Okay. So once you understand how you can use it for training, and once you understand what actually happens in a race, right? What actually happens to your position when it counts, you want to start to improve it. You want to start to improve your position, right? And for the time trial, that's, there are many, many options what you can actually do, right? So you maybe want to try to find a position which is maybe more aerodynamic, more comfortable. I just mentioned a little bit, like you want to do a shoulder shrug. You want to try to get lower with your head, right? Whatever reduces your aerodynamic drag, try that. And then create a new target range for this improved position, which is maybe even more difficult for you to hold, right? And then you want to use this in specific training interventions, okay? And what I'm going to show you now is kind of the bread and butter, so to speak, interval training sessions for time trialing, okay? So most simple, 4-minute sessions, a little bit above FTP maybe in that range, okay, with approximately a 6-minute recovery at 50% FTP, where your recovery is the fastest. This would be a good typical training session to use this, because you want to be short, right? You don't want to be super, super long with this new position, because what you're going to see most likely is that you have trouble to keep this improved position, okay? And therefore, a shorter session, like 4 minutes, a shorter interval, and a longer recovery of like 6 minutes, right, is really recommended. And what I would recommend also to do is in the 6 minutes, not even to try to think about the position, right? When we would do aerodynamic testing on the velodrome or on the wind tunnel, and we have the athlete actively changing his position, actively trying to be in a shoulder shrug or similar, you have to kind of, so to speak, reset the mindset or reset the thinking of the athlete. If in between the runs, in between the trials, you have your athlete still trying or thinking about this different position, it could actually mess up the measurement. And it's a little bit similar here. You really need these 6 minutes in between to just pedal easy, not even stay in aero position, go on the drop bars, something like that, and don't even think about that. And once you are familiar with that, increase the time, right? Increase the time, for example, 3 times 10 minutes. You may want to lower the intensity a little bit, but still stay somewhere in the ballpark of a potential TT race intensity, okay? And then obviously the final one, so to speak, would be to go to a very, very long duration, like, try to hold it for like 30 minutes. And therefore you're allowed to lower the power again, go a little bit below threshold if you want to, increase it later on, so to speak, and try to go 30 minutes at 100%, that's fine as well, okay? So that's the third step here, right? To improve your position here, okay? And then take it a step further, okay, and max out, try to max out one of the metrics. And what do I mean with max out? You put, you choose, you focus on one metric. You just focus, for example, on torso angle, or you focus very, very nicely for a nice technique. What you really should look at, you look at pelvic rock, because what you will see with pelvic rock, when your position is not perfect, you can see very, very weird high numbers here, okay? And then during an easy session, try to go to the limit for this value. So try to ride with like a 0 pelvic rock, or try to ride with your lowest torso angle value, okay? And then instead of increasing the intensity or something, right, you are looking at the time it takes you, the maximum time you can hold this perfect position, okay? And you will see that in the beginning, it maybe is very short time. It's maybe even almost impossible, for example, to have 0 pelvic rock. Now, one of the nice things when it comes to training for position in comparison to training for higher power output is adaptations and technique are much, much faster. Much, much faster. One of, actually, the first scientific study that I ever did in 2001 was to look at metabolic changes by forcing people to, so to speak, round pedal. So by forcing people to pull up in the upstroke to see what is the metabolic physiologic effect that comes with that. And also there, you were able to see that it's very quick. It only takes a few sessions to really improve the technique, to change the technique. And that's something super nice about technique and posture training. It's, it's very satisfying, because you can train for higher power output, and it might take ages until you see any kind of improvement, if ever. And the nice thing about what we're talking about here tonight is, it's relatively easy to achieve better results. So therefore, it's much, much more satisfying. And that's the same thing here. Right? You will see that the time that it takes you until the good number or the target number of 0 pelvic rock or lowest torso angle, is ceasing. The time will improve pretty quickly. Okay, and very important, similar to what we said before, release entirely for 5 minutes. Right? Entirely change your position, relax your mind, not try to concentrate all the time. You either concentrate on it 100% or you let go 100%, okay? And obviously the goal is really to increase the time there, and increase the time you can stay at your personal best value, okay? And your personal best value may also change, okay? And then training tip for better position number 5 is a little bit specific and kind of closing to what I started with the indoor training. When you train indoors those days, what you might have noticed is seating problems or seating pain, right? Especially riding indoors. It's something that it's pretty common for people. And then you think about it now, when you go outside and train outside, especially when you climb, you maybe actually never have these problems of the seat pain. You maybe don't experience that. The question is, why is that? And it's the same reason, by the way, why after a hard long ride, you maybe have pain in your quads when you climb some stairs. Because what's happening when you ride your bike, you push down on the pedal, like in this position here with the right leg, you push down on the pedal, and the idea is basically you do a knee extension. And what you're trying to do with that, you're trying to apply force so that the pedal goes down. Now this might sound, very, very like super, stupid simple. But again, that's the same kind of movement that you do when you climb stairs. This is why after several hours of hard bike riding, you might have pain in your quads, because this is the same movement as you do on the bike. So funny thing is, when you climb up some stairs, the idea is you do a knee extension, And the idea is you lift your body weight over to the next step. When you do the same movement on the bike, your intention is to get the pedal down. And what's actually happening is when there's a force, there's also a counter force. So when you ride your bike and you push down on the pedal, not all the force that your leg produces is actually used to push down the pedal, to push down the crank arm. A significant amount of the force is actually used to lift you out of the saddle or unload the saddle, better to say, okay? And this is the reason here, when you ride indoors all the time, especially, for example, the higher cadence, lower power output, the lower the power, the higher the cadence, so the lower the torque, the lower the force, the more body weight, so to speak, is actually on your saddle. And the higher the torque, the more you're going to unweigh yourself on the saddle, okay? And again, as I said in the beginning, I wanted to talk, about becoming more efficient. We talked a lot about becoming more efficient by getting more aero, but the other thing is you cannot afford to lose force. If the force is there and you have a certain force in your knee extension, then you don't want to lose it by unweighing yourself on the bike. And a good posture is, king and key here to that, okay? So what you want to do here in terms of training, first you want to make sure that you're warmed up very well. And the exercise here is nothing you want to do, from zero to hero. You don't want to do it immediately. You want to step by step get into this training. So what you need to do is you need to ride on, a low gear, high torque, just as we said. And you want to start to use your standard range for pelvic angle and pelvic rock. So you want to use your standard range, which you have from the normal torque efforts in the target range. And a recommended intensity, and this is why I said you have to do it step by step, would be approximately 3 to 10 minutes at 80% FTP. So you have to go below threshold. I do it with the professionals at threshold. But again, it's very, very hard on the knees here because you are going to stay at a cadence range of 50 to 60, right? And the goal is to really stay steady and to stay low on your pelvic angle, okay? It would be actually nice to also see something, how good is the abutment, how good is the counterforce, how much actually are you able to pull yourself into the handlebar, because this is where you this is how you close the loop here, make sure that you don't lose the force. But looking at pelvic angle and stay low with the pelvic angle and don't open up is something very important. And just intuitively, if you think about it, when you go very hard, and thinking about this image of the Swift rider I showed at the beginning of this presentation, when you go hard, you easily, as I said, you lose your position when you try very, very hard. So, and losing this position often comes with opening up the pelvic angle. So try to stay low on the pelvic angle, and then also try to stay low in the pelvic rocking, okay, especially with this low power output. Very, very simplified term here or mark to put on this: try to be smooth, try to be as smooth as you are when pedaling at high cadences, because again, you don't want to afford losing force here. Similar, like you don't want to afford to have higher aerodynamic drag. Being more efficient, right? Use the force and use the power that you have. And by this, close. Thank you very much for your attention, and can hopefully go for more questions.